Thank you very much. Good morning, everyone. Thank you for coming. I appreciate it. I see a few of my colleagues here in the room. I am glad to finally teach you something today. My name is Jakub Słowiński. I am Senior Software Engineer in Stepstone Services. Our main development office is located here in Warsaw. I am here today, I'm so big. I am here today to tell you about my experiences with progressive web applications, with implementation of such applications, and give you a few hints on what to do and what to avoid while doing this. Let's get straight into it. We will go like this. First, I will introduce the topic briefly, present a few definitions, answer a few questions that come to mind instantly. Then we will go through basic requirements of such application in fundamentals. Then we will discuss requirements related to performance and user experience of the application, with special emphasis on offline support. And then we will discuss requirements that are not really requirements, are optional on the performance web application checklist, one of them being push notifications. Okay, let's go straight into it. What are progressive web apps? Let's try to define this term first. The term was first used by Alex Russell in 2015 in one of his blog posts, and since then have been promoted heavily by Google developers community through their documentation, through their events, some of them even dedicated to this matter, such as Progressive Web App Dev Summit in 2016 in Amsterdam, which I attended happily. So in order to answer this question, let's use Google's definition of progressive web application, which is progressive web application is a user experience which has reach of the web and is at the same time reliable, fast, and engaging. In the other words, it means that progressive web application will be an application that attempts to provide to its user some certain functionalities that are typical to native application, such as prompting to add your website to your user's home screen on his smartphone so that he can run it instantly from there. Then it can render without browser context, without border of the browser, with custom splash screen, with your own icon, etc. It can start up instantly and work offline, just like native application. And using those techniques, you can enable some advanced enhancements, such as push notifications, which are also typical to native. But at the same time, your website stays a website, mobile website, which maintains all cool features of mobile websites, such as the fact that it's easy to find and easy to access through simple URL, which you can easily share across the devices and between people in a form of link. So your website might actually already be progressive web application according to progressive web application's baseline checklist, because the baseline checklist is mostly about good web development practices in general, which your website might meet already. So the chances are that your website already is progressive web application or is very close to being one. How do you know how to check it? Easiest way will be using a Lighthouse tool, which is provided by Google, originally as an extension to Chrome and Node module and command line application. Nowadays it's available in your regular Google Chrome DevTools. So the easiest way would be to run your application, run your website in Chrome, go to DevTools, go to Audits tab, and click Perform an Audit button, which will present you with detailed report in 4 different categories: progressive web application, performance, accessibility, and best practices, marking your page against some predefined, arbitrarily defined by Google requirements in those areas. By the way, Lighthouse report produces not only a list of what's wrong with your website, but also a list of hints on how to fix every single one of those issues, which is cool. But the issue with Lighthouse is that it doesn't check all progressive web application functionalities. And this is stated directly on Progressive Web App Checklist by Google on Google's developers portal, that some of those items on the list cannot be checked automatically by Lighthouse, which means that you will have to do it on your own. And we will do exactly this today. We'll go through Progressive Web App Checklist, which is divided into baseline checklist and advanced checklist with optional items you can include in your progressive web application, and we'll try to implement each one of them based on 2 test cases that I have selected, two significantly different applications. One of them being my private blog, which is very small, very simple, straightforward React and Webpack application. It doesn't have any target audience. In fact, I created it just as a playground for my private projects and testing some new technologies and stuff. On the other hand, we have commercial product, which we are developing in Stepstone within our team. The product is dedicated, designed for HR employees, recruiters, which are often corporate clients. So it has very well-defined audience. Naturally, it comes with much more complex logic and business requirements, which is then represented in the technology stack chosen for this application, mainly in Redux, which is added, which is single application state management container and toolkit in general. By the way, my blog doesn't have any backend implementation. It is just purely front-end React single-page application, while in this commercial case, we had to take into account back-end implications. Okay, that's it when it comes to introduction, when it comes to defining what is progressive web application and how will we look at it today. Now let's go through the first section of our requirements, which is fundamentals. Baseline checklist presented a few slides before. Consists of 8 items and is available on Google website, on Google Developers Portal. Consists of 8 items which are in different order presented there. I am presenting them in my own order, which I find more convenient for this purpose. So let's start with the first one. The first one that I selected are the most obvious ones. We will get them quickly. Site is searched over HTTPS is the first requirement. Obviously, you cannot be progressive if you are not secure enough. Just do it. Another one, site works cross-browser. This is also something obvious and simple on one hand, might be implemented in very different ways on the other hand. One thing to note here is that Lighthouse will not check this for you. Lighthouse runs only in Google Chrome context, which means that you will have to check it manually. And you will also have to define what works means for you in your case on your own. Might mean that you display information that your application doesn't work on this browser, and you can have this point satisfied. Up to you. Next one also is quite obvious and related to the previous one. Nowadays, with modern web, every page that wants to be considered progressive has to be responsive. It can be achieved in many ways. I will not dive into this because probably all of us know how to do this using Bootstrap, Material UI, or whatever you want. One thing to note here is that Google recommends and suggests testing your website's mobile friendliness with Google Mobile Friendly Test, which is linked here. You can find it on the web also. But I think Lighthouse measures very similar points to this test, so you can use also Lighthouse reliably to check if your website is responsive. Okay, now into some coding actually. The fourth point is each page has a URL, and it might be easy to satisfy and obvious for standard architectures of applications, but in case of single-page applications, both of our applications are single-page applications, it might be an issue because whole routing is on your front-end side, not on your back-end side. And for this purpose, we are using in both cases React Router library, which is probably also commonly used by you, which is the most common routing library for React applications. And this is the first time, but not the last time, when this library saves the day. It really comes out with really nice, neat features out of the box, which you can use on many different, in many different purposes. This is the example of routing using React Router from my blog. A very simple example. You can see I used 2 standard components from React Router library, and each path of my application is matched to a separate component, which I display conditionally. This is a similar example from our production app. It uses switch instead of browser router, but the mechanism is very similar. You can see that here there is, instead of component, we provided a function that renders a component, but it works the same. And using this kind of implementation, you might be sure that with whatever path your user comes to the website, it will be at least handled by not found component, which meets the requirement of each page having its own URL. Simple, few lines of code. React Router does the job. Let's not discuss it too much. Next one is actually quite fun one. It's about providing metadata for adding to home screen. So your user is expected to be prompted with question to add your progressive website to his home screen. From then, it might function as a kinda like native app, emulated, simulated native app. In order to prompt him, it seems like a big feature and rocket science, but in fact, I really can't imagine how they might have done it any easier for us. The only thing you need to do is to provide so-called web app manifest, which is a simple JSON file, put it into the head of your website. This web app manifest is well documented on both W3 and MDN, so you can't be wrong with it. It has full support, full documentation, I mean. I'm sorry. And this is an example from my blog of such manifest JSON. And as simple as it is, it provides me with a few cool features out of the box. Which ones? So my application is, my website is now an application, right? So not only will I prompt user to install it as an application on his smartphone, but I will also, when he will run it as an application from his smartphone, display custom splash screen with custom icon instead of browser and borders, etc. Those things are done by icon property and background color properties, and two simple lines or a few simple lines, and you have splash screen like this. Another thing you can define here is theme color, which then changes address bar color of your website to the one of your choice when user is visiting it using browser still, not when he has it installed as an application. This and plenty of other cool things can be achieved quite easily using this web app manifest file. And as you can see, it's very easy to craft one and provide it to the head of your website. So it seems fishy. And where is the catch? What is wrong with this? It's just too easy to work just like that. And of course, there is a catch, and the catch is, of course, in browser compatibility. As of now, Web App Manifest standard is only implemented in the Google browsers and Samsung browsers, surprisingly. Although Samsung is quite up to date with this progressive web app enhancement. Microsoft and Apple are lagging behind mostly, and in this case as well. And Mozilla as well is not supporting this standard, although it has been confirmed by all three of those companies that they are working on implementation of this in their website, so it might eventually become an actual standard respected by most common manufacturers of our browsers. In Firefox and for Androids, it should come out with the next version, by the way, version 58, or maybe it's already online, I'm not sure. Okay, that was the fundamentals. Closing one was the one that enabled us to add our website as an application to the user's smartphone. This is basic functionality of progressive web application, but this is not enough. We are not there yet. In baseline checklist, you will find a few requirements related to performance. One of them being first load fast, even on 3G. So your application, for the user that never visited it, should load for the first time quickly enough, on 3G network. This is then described in details on the checklist as time to interactive. Your application needs to be interactive in less than 10 seconds on simulated 3G network. You can simulate one using Google Chrome DevTools and run your website with simulated 3G network, and then you can measure if you make it too interactive, not to first paint, but too interactive in less than 10 seconds. On the other hand, Lighthouse provides much more detailed and sophisticated performance reports measuring other metrics such as first meaningful paint, first paint, etc. But those are not respected by this progressive web application checklist. There you only have to be in less than 10 seconds on the first load. So it clearly calls for optimization for performance of your code. And it highly depends, obviously, on the technology stack that you are using. In our case, we are talking JavaScript. And with JavaScript, and if you want to optimize it, you will never be wrong with going to reduction of your package size or trying some advanced caching strategies. However, in this case, we are talking about first load, so caching will not help. We will focus on reducing package size for JavaScript. First and most obvious, minification, uglification. I believe that all of you are familiar with the idea of removing white spaces, renaming your variables to something less meaningful so that your final code takes less much space and it can be still understood by your browser. Let's not dive deeply into how it's done because it's quite simple, but I want to highlight a very important fact about this. This is the block application before and after minification. As you can see, almost 3/4 of it are gone just by one simple operation. You can reduce the payload of your application by 3/4 simply minifying it. Although I believe that you're already doing this, because given how simple it is and how effective it is, I believe that it's a must-have for every JavaScript application. Also, not only for JavaScript applications, generally when you are serving front-end, it would be nice if you compressed other resources as well. It will help you to make this 10 seconds on 3G. Most commonly, those are images and fonts that we don't compress and ship with big payload to the user. This is a simple technique to compress images using Webpack. Optimize them, yes, on the build time. Okay, but those are very simple, obvious techniques. I don't want to waste time on diving too deeply into those. Let's see something more complicated. Another idea to lessen size of your package that you are shipping to your user in terms of JavaScript would be to split it to only what is really required based on the actions that user is taking. One way to do this is so-called route-based splitting of your code. And in this approach, you want to, on the build time, split your code into chunks that represent different routes that user can take. When user is entering route 1, as in this example, you are loading him HTML, CSS, some entry chunk of JavaScript that is required, fundamental for your application, and then chunk related to the route that he's taking. For example, he went to user settings. He doesn't need to load whole rest of your application, whatever it is doing. It might be significantly bigger than only user settings route that he is taking. So in this approach, you are dividing this application into pieces that may represent this given route, and you serve those pieces to your user automatically. Additionally, you can preload or lazy load those remaining chunks if you find it convenient. For example, when your user is browsing through the list of items and he's scrolling down, you can already preload chunk representing the next page of this list if you expect him to go to the next page. This is advanced, but this is possible with route-based chunking. How to achieve route-based chunking? Simply using React Router. Add bundle loader package for Webpack to it, and you will be ready to go. Everything is described very clearly and in details in React Router own guide about code splitting, and it requires literally using a few predefined already built-in React Router components, elements, to split your application in such way. Another way of splitting your application would be component-based splitting, and this is the example from our production application from some time ago. Similarly to route-based splitting, component-based splitting relies on ECMAScript's dynamic imports, as you can see in this case of our own private implementation. You might go for this kind of vanilla JS code, but you might also want to go to some predefined library for this, in which case I would suggest you using React Loadable. React Loadable also utilizes dynamic imports from ECMAScript, but provides a wrapper for you to, similarly to this one, by the way, which was developed by us privately. This one provides you automated wrapper for your component, which allows you to provide loading indicator as well in the same place, and easily display it while you are loading a chunk of your application related to containing other components that your user has requested. By the way, advanced usage of this React Loadable may enable some customized rendering, preloading of components in an easy way, lazy loading in an easy way, and also some support for server-side rendering if you are using it already. And one cool thing about React Loadable is actually in its documentation. There is very detailed article by its author of the library, discussing differences and similarities, pros and cons of both route-based splitting and component-based splitting. If you will ever face a situation where you want to decide which way to go, how to split your application, please read this article. It gives you very detailed theoretical foundations on which approach has what purpose, basically. Okay, how else can we quickly reduce sizes of our package? One option is to go for gzip compression. Gzip is typically the format that your static resources assets are compressed by your server on the fly whenever they are requested. You can gain a little bit by pre-compressing them for your server before you ship them to the server so that it doesn't have to compress them on the fly. It's a small gain, but it's still a gain worth it. Prepack library from Facebook enables partial evaluation of your compiled code, which enables in turn removing some certain unused functions or performing certain calculations on compile time instead of in runtime. On some specific applications, in some specific cases, it might give you pretty significant boost, lowering size of your package. Tree shaking, method commonly used in other programming languages which are modern. Finally, JavaScript is modern as well. In ECMAScript 2015, they introduced tree shaking algorithms. This is the technique of removing dead code from your application due to some dependencies, for example, which were interfering with each other, or which is there due to some other reasons, whatever it can be. Whatever is not used from in your dependencies tree might be removed using tree shaking techniques. Another thing for React users, upgrade to React 16. Sheer package size of this newest version is significantly lower than previous versions. So it will also help you gain some space, gain some less size of your package. Anyway, I don't want to dive too deeply into those, although I did already. Performance considerations are major part of progressive web applications. This is the movement, the idea of PWAs is mostly about performance. It connects with serving your stuff to the mobile user on 3G and when he's offline, etc. But everything is about performance and optimization in general. So if you'd like to go deeper into this, please research those terms and see what you can do with your application. But I will not discuss it now. Next point, simple one, quick one, you're related to performance and user experience, mostly to user experience though. PageNet transitions don't feel like they block the network. So the requirement is that whenever user interacts with your website, clicks something or whatever, you instantly indicate that the request was taken and that it's being processed. One way to do this, and suggested in the baseline checklist, is so-called skeleton screens. You can see them often on Facebook or on LinkedIn. This example comes from LinkedIn. But it can also be good old loading indicator displayed immediately after user took an action, which requires some time to complete, and disabled as soon as the action is completed, of course. This is very nice and small piece of code I liked a lot and wanted to share with you. This is the simplest implementation of so-called skeleton screen I have found. So this main element, all elements inside this main element are styled and animated by separate CSS, which makes them look like the skeleton, like something is loading, while the root element is actually an element to which React package, React application is unfolding, mounting. So when your user enters the website, until React kicks in and mounts properly, he will be presented with skeleton screen basically written directly straightforwardly in the HTML and CSS. Very nice feature, but will not help you with loading indicators when you are already using your React application. For this purpose, common pattern would be storing loading in state of your application or state of your component, and displaying this loading indicator conditionally based on this field from state. To those of you who are familiar with React, it should be readable. To others, I'm sorry, I will not dive into React today. Okay, so this is how we can improve user experience by making those loading animations not clunky, maybe. Anyway, next thing, also related to performance, but the big one is working offline. How to make your progressive web application work offline. Native applications are working offline for the most of the time. Worst you can get is it runs, but it tells you that you need internet connection to actually use it, but still it runs. So this is also the requirement for progressive web application. When you don't have access to internet, you run this website, it should respond with custom information, you can't do anything because you don't have internet. Or if you can do anything in your website without internet, also fine. The only way suggested how to do it is service worker, and this is probably the only way there how to do it currently. So what is service worker? Service worker is technically, this is a new API introduced in some modern browsers, not all of them yet. I will show you compatibility in a second. But the API runs in the background. I mean, service worker runs in the background, and it's separate from your web page and doesn't need user action to kick in, to do something. It enables, for example, push notifications to be sent when your user is not directly interacting with your website, which I will talk about in a second. Other uses of service worker would be some customized caching. You can set up many different strategies for caching of your resources, or background sync, which is still very lacking browser support, so not really useful. Anyway, this is promised for future. Also for future, this is from Google Developers Portal, so it seems like real commitment. For future, they expect service workers to be handling periodic synchronization, for example, automatically redone every period of time, and geofencing functionality, among others, which are also available to modern web, let's call it. This is how service worker, so to sum it up, service worker is just like programmable proxy between you and your user, which you can use to cache your resources in a custom way, to send him push notifications, to synchronize in the background, and basically do many more things if you think about it and find proper use for your ideas. But let's see it in a second. This is browser compatibility, currently supported on plenty of them, not that bad. Still Microsoft and Apple lagging behind, but they will be there next year probably. It's already confirmed officially by both of these companies that they are working on implementation of service worker in their browsers. Anyway, because I know that this is main concern when it comes to progressive web applications, that they are not working on iOS systems. They are working on iOS systems, some of the features are not working, but this one will be soon, happily. So, no matter what you want to do with your service worker, you will have to go through three first stages of his lifetime, which is registration, installation, and activation. And then in the first stage, which is idle, you can actually perform your actions and do whatever you want with it. Registration is a simple operation. Technically, service worker is an object in navigator object scope provided by your browser. So you should check if it's there, if this browser supports this feature, and if yes, you can register service worker easily, passing to it as a parameter path to the script in which actual service worker is. This is only installation, registration. Actual service worker will be in a second. Important thing here is scope, which I'm console logging in success scenario. Scope is basically, scope defines what kind of resources you can cache with your service worker. All resources that are in this scope can be cached, intercepted by service worker. Everything that is outside of this scope cannot. Which means that probably most of the time, and scope is defined by the place in which your service worker file is on the server. So in other words, most of the times you want to have it in the root directory, so it can intercept any call that starts with your domain, simply. Installation of service worker, two important things here, cache name and URLs that you want to cache. So in installation process, as you can see, we are opening a cache of given name, and we are adding certain resources to it as we defined using cache storage API provided by browser. Those resources will be cached beforehand. They will be like the first one cached by your application, and whenever user refreshes it, he will get those from your cache if you program it properly. And the cache name. Cache name is important thing, but actually when it comes to activation. Activation is an event that takes place immediately after installation, unless there is already working service worker on your website. So if you replace current service worker with the new one will not kick in until user kills the old one, which means until user closes the website. then the activation event will kick in, and inside this activation event, you can easily remove cache related to your previous service worker if you would like to. And that's why I said that cache name is important, because it can be used for cache busting simply in this case. In each next version of your service worker, you can provide different name for the cache if you want to bust all previous caches on your users' devices. Okay, simply enough, those 3 steps took us to this page. This is part of Google Chrome DevTools again, a special separate service workers page that allow you to debug them a little bit. As you can see here, we see all service workers registered by this website on which I am running this DevTools, but if you check this little check tick at the top, which says show all, or if you go to this tab, you will see all service workers that you have registered on this device currently, not only related to this website, which is interesting experience. I encourage you to try it, because you will be surprised, I think, by how many of them are already there and how many big players on the market are using this technology. You will see plenty of YouTube or Facebook service workers there probably. No. So, once we have the service worker set up and ready to work, what can we do with it? Simple case, as I mentioned before, would be to intercept fetch events and return content from cache if you have one in cache. This is the example from Google's basic tutorial on service workers. This is the simplest case of implementation of your own cache strategy in service worker. Of course, probably you can imagine already that there are plenty of different strategies and ways to go from here. Having such a control over all requests that are done on your website. Some of those ideas were described by Jake Archibald in his offline cookbook, as long as in 2014, I think. More updated, more up-to-date and more sophisticated documentation is maintained by Mozilla in Service Worker Cookbook. And there you will find plenty of different, they call it caching strategies, but for me they are more like ideas on how to actually use your service worker. Let me show you some of them. This is network first strategy, in which any call is intercepted by service worker, goes to the network, and then if network responds, it will update the cache and at the same time serve the same content to the user. When the request from the request to the network results in failure, then he will revert to cache, of course, which is not included on this image, and serve content from cache. This is useful for API calls, for example, where you want to have the latest data, at least try to have the latest data always, and store the latest data in your cache so that when user is offline, this is what Facebook does. You are on Facebook, when you're online, you see the latest infos, but when you turn offline and you will visit Facebook again, you will see the same stories that you have seen because they are already in your cache. It will not go to the network because you're offline. It will serve them from your cache, and this is exactly this idea. Another idea, cache first strategy, would be better for serving static elements of your website, which probably didn't change since last time and can be reliably served from cache, and then in the background optionally updated based on the network or not. Those two approaches we have combined in our professional work in Stepstone into something which is sometimes referenced to as upshell model. So a model in which you implement your application in a way so that it's divided into the shell, which is static and doesn't change often and doesn't have to be taken from the network all the time, and the content which is taken from the network all the time. This is our implementation of this little cool feature. As you can see, or probably you can't see, but as you can assume, in dynamic URLs variable, there is list of APIs, endpoints that our application can call for some data. And if request comes with such address, then we go to the network first. Otherwise, we try to retrieve it from cache and revert to the network if it doesn't work. Thanks to the catch at the top of this promise chain, in any case, using this kind of implementation, you will display your user some error notification, no matter if it was found in network or in cache. given, let's assume that you didn't found it neither in network nor in cache, you still display an error, so you handle gracefully your lack of data to the user. You handle users' offline status gracefully, actually. One important thing here to note is that with every successful call from network, we fire update cache function, which saves the network's content, response content to the cache. So that whenever it's requested for the next time, we can serve it from cache. Using this, given that your user was already on your homepage, he can reliably display homepage again when he's offline. He can reliably recreate each path that he has taken thanks to this kind of implementation. By the way, the service worker is considered supported by a given browser only if it supports also fetch API and promises and all other things, so we don't have to take care of it. Here, it will not even happen. Service worker will not be registered in the first place if those things are missing, so no need to handle them in custom way. So, sorry. In order to implement service worker, you can do it just like we did and write vanilla JS code, which is nice for learning and for really custom control of your cache. So maybe for some very advanced production examples. But in general, it's much more convenient to use one of predefined tools such as SW libraries, which you can include in your application build time, or pre-cache Webpack plugin or offline Webpack plugin, which you can include in your Webpack configuration so that they provide your add service worker code to your code based on some strategy that you define in configuration. You can also count on it. There is a chance that you already have all of this set up. If you are using some predefined boilerplate, like create a React app, which is the most popular one currently, and it comes with web app manifest and with service worker with some simple basic automated caching strategy just out of the box. So if you are using it, you probably already have all of this set up. And that's it. I mean, that's it when it comes to basic progressive web app requirements. Having met all of those points so far, you will be officially considered as progressive by Google. Now, there are some further considerations you can think about while developing such applications like we did. For example, you are now offline ready and working offline, but only in read-only mode. Whenever your user wants to take an action which requires writing some data and he's offline, well, you need to disable it because there is no way to handle it for you. Here comes Redux offline library. I encourage you to check it out. It enables you to perform all those offline actions, and combining it with background synchronization of service worker, you could theoretically even update the state of your applications, fire all the actions that user taken as soon as he's back online. No matter if he has this website working or not, it will update the state. Theoretically, of course, but this is something to consider if you want to go further this way. Okay, quickly, let's see what we have on optional checklist of progressive web application. As I mentioned, the page which contains baseline checklist, it also contains exemplary checklist. Exemplary checklist is over 20 items divided into 6 separate categories, and I will not dive into them. I will dive only into those push notification one at the bottom. Although I had plans, but now I don't have any more plans for different topics than push notifications. So let's go with push notifications. What are those? We all know them probably from our smartphones. Easy, simple way to re-engage your user with your application because it doesn't need your application to be working to fire. You can fire push notification when he's not using your application, and then he starts using your application because he just received a notification. Obviously, this is very common on native apps, so it has to be replicated by progressive web apps. And this is how to at least attempt to do it. Technically, push notifications are enabled by 2 different APIs. Web notification API, which is supported better than web app manifest, and push API, which is also supported better than web app manifest. Okay, in order to provide such notification to your user, first you have to ask for his permission, obviously, and it can be done with notification API available in some browsers, as you could see. This call will trigger such window on Chrome. On other browsers is handled differently, and then in the result variable you will have information what actually he clicked, allow or not allow. One of the requirements on PWA checklist, by the way, and the one that makes sense to me, is that you provide controls not only to enable notifications, but also to disable. You can do it from your browser options, of course, but it's just nice to provide this kind of feature to your user. Imagine simple checkbox which can be implemented in React simply, but how to switch this setting on user click? Well, it's not that obvious because turning off notifications is not part of notification API. It's part of permissions API. So that's how you can revoke your permission for notification, or actually user can revoke his permission. Okay, now how to send a notification. This is a very simple example. As you can see, to send a notification, we will need service worker registration object, which is a result of service worker registration promise, and it has simple methods show notification. The notification itself can be very sophisticated. It's very simple in this case. It takes only one required parameter, which is title. In other cases, it can contain icons, badges, images, whatever, even vibration pattern for your phone to play some vibration music when notification comes. More importantly, though, it contains actions. You can define custom actions that can be performed on your notification, and you can handle them easily in your service worker using notification close, notification click events. And of course, you will, as we defined in those actions, yes and no, the same values come back in the action variable, so you can have a switch based on what user clicked, perform different actions. Okay, this is very easy so far because it's only front-end work. It relates only to front-end part of your application. And using this kind of, syntax, you can, or this kind of syntax, you can easily trigger notification to your user from the front-end side of your application, which is not fully satisfying because it means that you can do it only when he's interacting with your website. When he closed it, that's it. In order to send him notifications when he's offline, you need to use push API, although this is quite a complicated matter. It requires separate subscription. The one that we did before will not work because user now accepts to receive notifications also when he's not interacting with the website, which is major change. It requires setting up a push service, which is separate piece of your infrastructure working based on web push protocol, separate protocol as well. And as I said, it can enable such notifications from the backend. Backend setup is quite easy when it comes to local machine. If you want to test it on local, this is example from service workers documentation. Using Node.js web push library, which enables you compliance with this web push protocol easily. However, for production environment, it's significantly more difficult to set it up, mainly because each browser provides its own push service, and each one of them needs to be handled differently. This is example from a web push library for PHP intern, which is also available. There are also libraries for Python, Ruby, etc. It's common. So in the documentation of this PHP version, you can see example of communication with different push services from Mozilla, from Google, and some random one. Once you have set it up, you can request a subscription from your user. As I said, it's a different one than the one that we asked for with notification API. It's quite straightforward. And easily receive a push event from your backend side, from your server, intercepting it in your service worker. In this example, we receive push event, and no matter what kind of push event it is, we will show user notification containing this description. It can be description, it can be content coming from the server. In this case, this content comes from the front-end side. So all in all, push notifications, without a doubt, may become another building block that, if utilized properly, enhance users' experience on mobile devices greatly, makes it much closer to actual native applications. Imagine case like this, that your user is entering the plane, for example, and on the plane he's performing certain set of actions with your applications which require saving, etc., adding some comments, ratings, I don't know, for example, and then he turns it off, lands, turns airplane mode off, and everything is being synchronized in the background automatically, and then he receives a push notification that his actions were done on the server side or whatever. This is quite easy to imagine, I believe, in modern world, but imagine a situation where it is not a rocket science and doesn't require to be a rocket scientist to implement such thing. And it also doesn't require any re-implementation of your whole infrastructure from scratch. It can just be your good old website progressively enhanced to the state of progressive web application. So the tools are there. All of them are at your disposal. You can use them. I hope that after last few minutes with me, you are now at least a little bit keen on how to use them, both for some basic implementations and for more advanced. That's it from me. Thank you very much. And can we have some questions? Should we? Do we have time? Okay, let's go. If there are any, of course. Right, cool, thank you. No, seriously. Okay, seriously. Thank you very much.